Hi, everyone, and welcome to the 2020 Qt Virtual Tech Con webinar, In-Depth Model/View with QML. My name is Mark Perez. I'm the Director of Sales in the Americas for the Qt Company. I'm going to be your moderator today. I'm pleased to introduce you today is Chris Probst. He's a Qt certified trainer and senior consultant from our partner ICS. Before I hand over the mic over to Chris, I just want to cover a few housekeeping items about the presentation in the webinar platform. So today's webinars are going to be available on demand after the live sessions. They are being recorded. So once the session is done, we will try to post them as fast as we can to the live event page where you can go and see those at a later time and digest the content that way. We will be trying to address any Q&A towards the end of the session. Down below, you'll have your Q&A feature where you can ask your questions. So thank you for that. So without further ado, I'd like to kick things off and welcome you to our speaker, Chris Probst. Chris, over to you.
Thank you. Thank you. So I'm just going to do a quick sound check. Can everybody hear me? Hello? I'm going to take that as a yes. All right. Let me first introduce myself. So I've been introduced. I do want to mention a few notes about the about integrated computer solutions, because I am a staff. I am part of the staff there. We are the largest source of independent Qt expertise in North America. We also provide some UX services through our subsidiary Boston UX, and we are also showcasing in this conference one of our products, which is called Greenhouse. It is part of the virtual exhibit, and this project helps other companies do rapid development. Essentially, you bring the mock-ups with, the input is the mock-ups with Figma, some business logic, and this tool, Greenhouse, helps with rapid development, and we're very excited about it. So I've been with ICS for about 14 years now, and I am just going to go quickly over the agenda. I'm first going to talk about the basic principles of model view. So the title of this talk is In-Depth Model View with QML. I will talk about model view when your data is dynamic, and I will talk about model view when your data that the model provides is encapsulated in a database. So I'm targeting people that are coming to Qt from other toolkits. I've seen people come from MFC primarily, .NET. And in those instances, what we all know as GUI developer is model view, or the design pattern known as model view controller. But I am going to define it. So model view controller is really a design pattern from the 70s, where the basic idea is that the tasks that you want to achieve for your user interface are really separated into three loosely coupled components. So the model, which provides the data to the view which displays the data in a, sorry, I'm closing the window, the data in a beautiful fashion, and the controller which traditionally was accepting the inputs, the user inputs, and converts it for the model or the view. Now, in the context of Qt, we don't really talk about the controller, because the controller is really what Qt Quick, what Qt provides. So we mostly talk about model view, where model is what provides the data and the view is what displays it. So the reason why we do model view is that we like to decouple the intricacies of a beautiful eye from what's typically called the business logic. And with Qt Quick, your UI will be in QML, and your business logic, or your model, if you will be in C++. And this nice separation has a lot of advantages. One is that you can independently develop the look and feel of your UI from the business logic that it is supposed to convey to the user. And within this paradigm, what we try to do is that we really want the C++, which is really the model or the business logic, to publish its states, to emit signals of its states. And the UI, so the C++, the business logic does not, as I've written here, know about the intricacies of the UI. Now, the C++ also provides an interface to the UI, and the UI is aware that there is an interface to the C++. So the UI can actually call C++ functions that we define. Now let's look at a really simple example. Now this will be familiar to Qt developers out there. When the data is static, what we typically do is that our model or our data is encapsulated, generally provided by a third-party lib. And what we typically do is that we encapsulate this data with a Q object. We encapsulate with a Q object, or anything that inherits from a Q object. And then if there is a one-to-one mapping correspondence from the C++ to the UI, what we can do is that we can define properties. And those properties can be invoked directly in the QML side. When we provide these properties, when we come up with these properties, we need to, of course, define a read function, a write function, and a notify signal. Now, this is really in the case where these are read-write properties that the QML can actually write. The write function, if it's not writable from the QML side, is not necessary. So we provide the read function, which the UI will invoke to display the data. We provide the write function which the UI will invoke if the user from the UI side wants to change that data. And we provide the notify signal that we put in the C++. And the idea is that the developer is responsible for emitting the notify signal when the actual data that this represents changes. So if we go back to our paradigm where the C++ emits the state of the data, if you will, one can say that the C++ emits the notify signal, and the UI under the hood, because this is done pretty much under the hood, will call the read and write functions, right? So of course, when we encapsulate our data with inside of this class, inside of a Q object through this class simple model, one of the ways we can export it, we can make it accessible to the QML, is by this code right here, instantiating it and then exporting it, and then this object can be referred to a simple model, the string that's right here. And if I need to display the speed property or the temperature property, I just refer to it as a simple model.speed or a simple model.temperature. And with the property bindings that QML provides through the notify signal, if these properties change, they will influence other properties that they are bound to within the UI. Now here I showed, speed and temperature. This is, common things that you see in embedded devices, but it doesn't necessarily need to be a number. One could imagine a property, for instance, to be a URL. URL being a QML screen, and the C++ determines what screen needs to be displayed, and I can bind this QURL string property to the QML loader component. There's a source property for that. Now, this, of course, there are tons of examples of this. This is, of course, really easy. And when I present this to the class, because I am a trainer, I often get the comment, well, this is great, but this only works for data that is static. If I have a multitude of speeds and a multitude of temperatures, or even a multitude of screens to display, this doesn't work really well. This gets pretty messy in a hurry. So, and not only that, if I have a multitude of speeds or a multitude of temperatures and I do not know how many speeds I have to display or how many temperatures I have to display, well, we got some trouble here. So that's where what we refer to as model view delegate, which is really a framework within Qt, comes in, right? So the idea is, and this is where model view is used explicitly, because in the previous example, model view was used implicitly, but here it's really used explicitly. And the idea here is that Qt Quick provides view classes that display the data. Qt provides model classes. And when we instantiate any of these view classes, we export the model classes from the C++ to QML, and then we set the model property of these views to be a C++ model. I will show an example. Now, I do want to talk about the delegate, because that's where the confusion comes in. Now, the delegate is not the controller, so to speak. I would define the delegate as being the individual, the UI specification of the individual items within the view. Now, I'll show an example to make it more clear. So here I did mention that here I do show that a model can be one of these two value classes, QString list and QVariant list. Now they are not, they are Qt containers. They are not explicitly model classes. They are value classes that can be used as a model. But the one that I am most interested in is, and the one that is the most powerful, is this one, QAbstract item model, which has two model classes inherit, which we can use. One is a QAbstract table model and QAbstract list model. Notice that here in the view, I've listed list view, which is a list of items. So there's just rows. There is grid view, which is a bit like a list view, but it is a grid, a two-dimensional grid. There is path view if you want to have your items, so your delegates, displayed following a specific path. Now, recently, table view was added. Table view was added. So table view it's your typical Excel row and column sheet. Now, I haven't listed tree view. There is, in fact, a tree view in the Qt Controls 1, which use is discouraged. Now, I have seen some talks from other Qt developer days where someone actually implemented its own tree view in QML, and I can provide that link. Long story short, implementing a tree view in QML is a bit tricky. All right, so let's go to an example. Now, to illustrate all this theory, one of the go-to examples that I use is this. So I hope that everybody can see my Qt creator. And so it's this go-to example that I show, which is really this this download manager. I don't know if you guys know about Napster. Napster was this program in college that I used to do to download awesome music. And here, this is a great example of where model view is useful, because I do not know at compile time, when I'm coding this, how many downloads there will be at a specific time. So here I'm downloading stuff, and let's hope that the download actually works. Yes, it's downloading. See how they're downloading at the same time? Now, some of the URLs that were provided here as suggestions don't work anymore. That's why you see this error on download. Now, so this is how it looks. And again, the way we would do this is that we independently develop the UI from the model. So the UI is really this view. So this is this view, which is a list view, right? And these things that you see individual are the implementation of the delegate. So let me show you what the delegate looks like. This is what the delegate looks like, right? So we give this to a graphic designer. You know, hopefully a graphic designer can understand QML. It's not hard. And so every individual item has these labels and a progress bar. And notice here, there are hooks to the model, right? So the text can either be the error text or it can be the actual URL. And this here is what we call roles that are provided by the model. This is why I prefix them with this model dot. Okay, so the idea is, first thing you do when you develop something like this, you have some fun and you develop a nice, beautiful UI with your graphics designer. And then the idea is that you can provide this delegate to a view. In this case, the view that I'm using is list view here. So here you have the list view, and here the delegate is this component MP3 item, which is here. And notice here that the model of this view is this MP3 list model. So let's look at that. The MP3 list model is in fact an inheritance from Q abstract list model, which in fact inherits from Q abstract item model. And again, so I talked about the read and write and notify signals. Now they're not explicitly referred to that, but one can sort of understand these functions that we need to re-implement as read, write, and notify signals. Data is really the read function. It provides the data for all the delegates. Data and row count, because row count provides the number of delegates that needs to be displayed, or that are currently in the model, I should say. The view will know if it needs to display them or not, all of them, based on what the user is looking at in the list, because it doesn't, the whole model is not exactly put into memory. And set data that you see here is the notify function. Is the write function. So let me show you what data looks like. Before I show you what data looks like, I do want to say this, that the individual downloads that you see are contained within this container Q list. Which is a Q list of these guys, which is, one could say that this is really a third-party thing. It is actually not a third-party thing, because I actually used the Qt Network Access Manager to do a particular download. I shouldn't say I did. This was developed by Ryan Hampton, I believe. So he did this. Okay, let's look at the data function itself, which provides the data. So here you can see the data function takes in an index. The index is really, in this case, the row number. So it's a location within the list view. This read function is really called by the UI under the hood on a per need basis. And when the UI calls it, it gives in the location. I need this particular row, and I need to implement this data function in which I grab the row, grab which download is being referred to, and whatever, based on the role, and I'll talk about the roles, based on the role, I provide that data to the UI. Now, let me show you. This would be the this would be here the other read function per se. So this would be the number of rows at a specific time. So here I am returning the size of the container. And this would be here the write function, set data. And notice here that in this write function, I am emitting this signal, data change, which is something that is given to me by the Q abstract list model, but it really can be seen as a notify signal, and it notifies that the item at this location right here, from this location to this location, these items have been changed. Now, if I add data, so if I add a download, this QInvocable function is called, and notice that here I embed the adding of a specific download between these two signals, begin insert row and end insert row, which signals to the data, to the view, sorry, that there are items being added. By the same token, when I remove, so this is a QInvocable function that can be directly invoked from QML. By the same token, if I'm removing items, I can embed the removal of these items between these two signals here, begin remove rows and remove rows. And here I'm specifying where the location of these rows in the view. Now, I do want to specify that this program is available. The source of this program is available on a GitLab repository, which we will make available, and you can have as much fun with it, and you can rip it off. We had a lot of fun to code this. Now, I do want to talk about the roles, okay? Now, the roles here are what you see here, this here, the actual data itself, right? The problem is that roles for the model, on the model side, are in fact enums that are defined here, right? And you have to, unfortunately, so this is the way it works, you have to associate the strings that are invoked in the QML with the different values of the enums in this function here, role names, which is provided by a Q abstract list model, which you have to re-implement. And here I have essentially associated the selected string with this role, the done string with this role, the progress string with this role, and this and based on that, the data function will be called with the particular role in mind, and the actual piece of data will be returned. Will be returned to the data. Will be returned to the view. Now, I did want to speak about the download itself, the individual download, which is not aware that it's part of a manager, but I do use the Q Network Access Manager class. And that means that really, I'm doing this because I do want to specify that Qt is a really good toolkit. If you, even for non-GUI stuff, it's a really good toolkit. Q Network Access Manager allows you to do a simple HTTP gets and downloads. Now, I wanted to talk a little bit about the database. I am running a bit out of time, but I'm going to do my best here. I wanted to talk a little bit about the SQL database model, because I've been sort of working on that. And this is so in our previous example, the data was contained within a Qt container, which is QList. But one can imagine where the actual data is encapsulated within a SQL database. And the reason why I show this is that it's super, Qt has a really good and easy to use framework to be able to provide, for the model to be able to provide data to the view if the data is contained within the database. And I'm going to actually start with here, this ship list program. And notice, now I could inherit from Q abstract list model and then call the Qt SQL database classes to do a query, and then have the data function return based on the query, the data. But the great thing is about this class here, which inherits QSQL query model, which inherits from QAbstract item model, is that this is the Qt folks have done this for me. And the idea here is that I can open a database. So this is the database that I open. Here I'm using a Qt class, which is QSQL database, right? So I can open a database, apply a query on it right here, apply a query, and this is where I do this. And based on this query, the query is in fact the data that will be shown in the view. And the nice thing is that the view will be aware. So here, if I go to my view here, if I can find it here, the text that you see, if I can find it, oh, wrong, no, if I can find the text that you see will actually refer to the actual fields in the database right here. So ID and name are actual fields in the database. In fact, I'm going to open the database right now. Open the database right now, right here. And here you have the actual database right here. Now, there is some work to it. There is this boilerplate code that you have to. I'm going to put this example online for you guys to hear. There is this boilerplate code that provides the data to the view, and the role names also has to have this has to be implemented like this. But essentially, if I have this class right here, which is not a long class, I can hook it up to any model, and as long as to any view, and as long as the view knows of the fields of the database, it can display these fields. And I'm going to build this, and notice here that here is the contents of the database. And I'm actually going to change here. I'm going to change. I know that Admiral Kirk was once, I believe, he was demoted to captain. I'm going to change that here. Now, I'm going to write those changes here. Now, for that to work, unfortunately, when you use with databases, if you change the database, the UI has to know that the database has changed. So somehow you have to create some sort of notify signal. Now, the notify signal is this refresh in Q invocable that I created. And if I call the notify signal, notice here, if all goes well, Captain Kirk on the UI side now, Admiral Kirk is now Captain Kirk on the UI side. Now, the reason why I show this is that if you are, this is sort of a way to have the database do the heavy lifting work that you generally do in the model. And if you can talk to the person who organizes your database and tell them, you know, this is what I'm displaying, can you provide some sort of a view within your database that I can just query, and that's all I need, and I have these fields. Now it looks like it is. So this was my first time. Thank you so much. This is, I really love this. This is my first virtual conference, you know, in extraordinary times. Thank you so much. I really had fun doing this. I don't think we'll have time for some Q&A, unfortunately, because I did have a lot to talk about, but I will make these programs available. Thank you so much. And I'm going to give it back to Mark.
Thanks, Chris, and fantastic job. It's a lot of interesting content. I know people are really excited about this one. So everyone, thank you for attending. Chris, thank you for doing such a fantastic job. Like we mentioned earlier, the link is going to be published as quick as we can, so you'll have access to it. And everyone, thank you so much, and enjoy the rest of the virtual TechCon, and enjoy the sessions you will be attending. Much appreciated. Have a good day.